we have to use some kind of multiple pump arrangement. So one is that where we need to increase the net head across the pipe pumping system. So it means that because usually, if you understand that in the electric circuit, sorry, let me pull it down and then explain it there. So in electric circuit, we have got two arrangements. One is if we arrange the resistances in the series, and one is when we have got arrangement in parallel, right? So these are the two arrangements, and both have got their own characteristics, right? So in the series case, the current remains the same. So I we represent current. So I remains the same. While we have got voltage drop, voltage drop across each resistance, right? In parallel case, the current is divided for the two parts, for the two resistances. I would rather say two resistances, two resistances, while the voltage remains the same. Remains the same. Voltage drop across both resistance, right? So now if I want to create an analogy for the pumping case, so I would here the resistance is just the loss, but if we replace it with the, it is kind of a same thing. But if we kind of replace it with source, then we can say that the resistance is analogous to pump in a way that it is providing energy. So now pump is the source. Current, what is current here? Current would be analogous to volume flow rate, and then voltage drop or temperature drop would be equal to net head gain across a pump. Right. So these are the corresponding quantities in terms of fluid mechanics. So now, if we want to increase volume flow rate, this one, then it means that we need to put the pumps in parallel, right? But if we want to increase the net head gain across a pumping system, then we need to put them in series. So it means that when we are increasing the volume flow rate, we need to put the pumps in parallel. And if we want to increase the net head rate, then we need to put pumps in series, right? Okay, so let's suppose that we talk about increase in net head value, right? First of all, we consider the case where we the net head available across a single pump that is 10 feet or 10 meter, whatever. So now if we want to have a net head, because we have installed the piping system, so we know that there are major and minor losses which are kind of 12 feet head of losses, right? So it means that we need to increase it by 2 feet. So we have got two possibilities, right? One is that we install an additional pump in series. But here, because 10 feet is already being provided, so it means that we only need 2 feet. So it means that the additional pump which would be installed, that would be a little bit of smaller size, right? So let me show it on the put that the schematic if I can show you on the whiteboard. So let me show it here. So that is the case. Okay. So now in this is pump one and this is pump two. So it is providing 10 feet of net height and this is providing 2 feet, right? So in theory there is no problem. But if we kind of look at the characteristic curves, we know that if we have got the characteristic curves of the both, it would be something like this. That for the pump one, we are kind of characteristic of net head curve. So this is something like this. And for the this is pump for the pump two, which is smaller pump. And then for the larger pump, we would have a characteristic of something like this. So if you remember that this is the free delivery points, free delivery points, right? For pump one and pump two. What is free delivery point? That if we have got a volume flow rate here on the x-axis, we have got volume flow rate. So if the pump two, if the volume flow rate through the this CT center, if it is somewhere here, this vertical dotted line, it means that pump 2 is kind of working beyond its free delivery operation. So it means that it is not going to give us this 2 feet, right? Because in order to get 12 feet in total, we need to operate the volume flow rate somewhere here so that it can kind of give us the additional 2 feet and the net output, let me show it with the with this, something like this, right? So then this red line would give us the additional 2 feet. But for that, we need to make sure that the volume flow rate is less than the free delivery condition of pump two. And if it is more than the free delivery, then it means that this pump two it is not going to give us anything useful. Rather it would be working as a free component which is giving us additional resistance to the flow, right? So it would do more harm than the good if the volume flow rate is more than the free free delivery mode, right? So it means that if we the conclusion is that if we if two dissimilar pumps having a major difference in their head volume flow rate values are stored in series or parallel, it would it can result in undesirable performance degradation. Okay, so this was the first of the two choices which we discussed here. Because the problem was one pump was providing us 10 feet and we needed 12 feet. So the first choice we did that we put an additional pump with having a net head of 2 feet. So it gave us some problem because if the volume flow rate is higher, then it wouldn't give us that 2 feet. Rather, it would increase the minor loss due to that component. So the second choice we can do is here that for the same pump, for the same pump, for the same singular pump, we can use pump with larger impeller diameter, which would provide us so it means that we only need to replace the impeller diameter, existing impeller diameter, with the larger impeller diameter. So it would give us something. If I told you the curve here, that if the impeller diameter is small, then it would be something like this, and if the impeller diameter is more, then the head curve would be like this. So this is one solution, right? So that is more preferable when we talk about a little bit increases net head or volume flow rate. But what if that?
सर एक
Yes,
क्वेश्चन है सर
yes,
सिंगल पंप के
please.
लिए दो पर क्यों क्यों हो गए क्योंकि सिंगल पंप नहीं यूज कर रहे हैं
Better
नेट
single.
का
If I can understand your question, you are asking that if we use single pump, uh, then we can get the 12 feet 12 feet head by using a single pump. Is that the question?
नो सर मैं सर क्वेश्चन कर रहा हूँ के साथ जो आप ग्राफ बना रहे हैं सर फ्री
जी
डिलीवरी और शॉर्ट ऑफ हेड वाला सर ये दो नहीं दो सिंगल पंप के लिए सिंगल ही बना था दो बनाया सर आपने ये एक रेड
ये
लाइन से एक
अभी
ये ब्लैक
अच्छा बिल्कुल ठीक है मैं थैंक यू वेरी मच फॉर द क्लैरिफिकेशन thank you very much for the question so that I can clarify this here. This is the characteristic for the same single pump. We are talking about single pump. Here the diameter D1 and D2. So what is D1? D1 is the impeller diameter uh, having impeller diameter lower value, right? And then D2 is the for the same pump with the impeller diameter little bit larger. Let me show it graphically. I will try to make a schematic of that. ठीक है? So here we have got a shaft. ठीक है? जो कि main shaft है जिसके ऊपर ये सारी rotating assembly भी होती है. ठीक है? So we are talking about that here we have got an impeller diameter of this. ठीक है? यानी कि इसके ऊपर हमारे पास वो रोटर ब्लेड और सारी चीजें हैं. तो ये हमारे पास D1 है. अब ये जो चीज होती है ये जो रोटर की जो impeller diameter होता है, it can be replaced with a larger impeller diameter, something like this. ठीक है? So it would have a diameter of D2.
यस
So now it means that when we have replaced the smaller impeller diameter with the larger impeller diameter, then it means that it can provide us with the more head or the more volume flow rate. So if the increase in the volume flow rate or the net head is small, then we usually change the we usually use the same single pump but with a larger impeller diameter. ठीक है क्योंकि जो भी पंप होता है it comes with different impeller diameter options, so we can always replace the smaller diameter with a larger diameter to achieve our objective of increasing the net head or the volume flow rate. ठीक है मेरा ख्याल maybe it is clear to you now.
यस सर
ठीक है. So we are talking about this option here, that it is more kind of practical to use the same single pump with the larger impeller diameter. But let's go back to the original problem statement. That because here it was giving us 10 feet. Okay, what is that the piping system suddenly requires 30 feet of 30 feet of 30 feet of net height, then it means that it is more kind of justifiable to use multiple pumps having similar kind of characteristic. Okay? So that if it is a slight increase, we can change the panel diameter. But if it is more than twice or thrice, then it means that there is no other choice rather than to use other than the use of multiple pumps either in series or in parallel. So now we are going to discuss those two cases that where we require the addition of the use of multiple pumps, right? When the requirement is multiple times of the existing requirement, then we need to do multiple pumps, right? So in that case, as I kind of explain the analogy between the piping system, pump system, and the electric system. So if we need to increase the volume flow rate, then we need to use the panel arrangement, and if we need to if we need to increase the net head across the piping across the pumping system, then we need to use the pump series. So let me write it in a formal way. So we can say that now we are discussing the pump in series. When it would pump in series, then the combined net head is the sum of the net heads net heads of each pump connected in series. Just to show it more clearly on a picture, let me show you the characteristic of those three pumps in a series arrangement. So let me show you the characteristic of those that just hang on a minute. I'm copying it. Okay. So here.
सर आई थिंक वो पुणे में सर ये जो
Yes.
पंप आ रहे हैं सर सीरीज में तो सारे हम इनको वर्टिकल प्लेस करेंगे हॉरिजॉन्टल प्लेस करेंगे
Okay. So that is excellent question. Excellent question. Usually we place them horizontally. Usually in most of the cases we put them horizontally unless there is a specific reason to put them in vertical position. Like if we are talking about the movement of the transport of fluid on a hill, then maybe we need to put it at a different elevation. But if we are talking about the transportation of fluid from a lake to some city, then maybe we would put them at the same elevation. Do you get it, Matt?
या यस
ठीक है, it depends upon a particular application, but usually we prefer them to put it at the same elevation unless it is unavoidable. Okay. Now here you can see the three pumps which are installed. So from this figure, if I kind of if you want to know that what pump is the larger one, that would be pump 3 because the it can have the highest volume flow. It can operate over a wide range of volume flows. So let me put it here. So it means that it is the largest one, right? So fluid is coming in and it is going out, and then it is being here. It has been coming down, and then here we would have a little bit smaller pump, little bit, not much. And then because we don't want to change it to very, and so this is kind of a centrifugal pump at the moment we are talking about. And then we have got another pump here, which is installed in series. So here we would have even a smaller pump, not the best kind. So now if I show you here that because this pump 3, it is the largest one. So this is pump 3, this is pump 2, and this is pump 1, right? So you can see the characteristics curve for the net head that is given for pump 1, 2, and 3. So if we are operating the system at a volume flow rate which is less than the these are the three delivery points. This, and this. This is the three delivery points of each pump. So this is the free delivery point of pump one. This is the free. I would put it A, B, and C. A, B, and C. So point A is the free delivery point of pump one. Point B is the free delivery point of pump two, and similarly, this is the point C is the free delivery point of pump three. So it means that if we operate it beyond pump C, there wouldn't be any useful net head being imported by this system, right? So if we operate it in between B and C, so the only useful work would be provided by pump C, but pump A and B they would be in free delivery mode. So it means that we need to kind of cut them off, meaning that here there should be some valve installed somewhere here, somewhere, somewhere here. So it means that we need to kind of from here there would be a key, and then we can take it from there, straight out of the system. Because if we operate it between point B and C, then if we take the fluid through this pump 2 and pump 1, they would be adding more losses to it because they are working beyond their free delivery point. So that is the thing that we need to make sure that they doesn't go in. So there would be a key. So uh, and a valve is stored here just to make sure that we have got we can cut off this flow through this, and all of the fluid would go through straight away out of the system. Okay, so in order to get the maximum head, we need to make sure that the volume flow rate through the piping system is on the left side of pump A, right? Because in that case, all the three pumps would contribute, and the combined losses, combined net head would be this curve, which is on the top of this, which is shown here. So that we kind of highlighted it. So this is the curve we are talking about. So it would increase the net head up to this point. Okay? After the first deadline. So if we increase the volume flow rate beyond point A, so it means that then the pump one would be acting in a ideal position. So it means that it wouldn't be giving us any useful net head. So at that point, it is better that we cut off the supply to that pump which is shown here. Let me show it. This one by using that valve, and from here we just take the volume flow rate which is coming out of pump 2 and take it out here, right? So I hope that you can understand it. And then if we increase the volume flow rate to point B or beyond point B, then it means that we need to even cut off the pump 2, because even at beyond point B it is not producing any useful work, right? So I hope that you can understand this point. Okay, one conceptual question here. What is this? If I show the point D here, what is this point D showing? Practically speaking, which is the top here, top point.
shut off and साथ में वो pipe
Shut
में
off
लगा
an
दिया था
accident. It means that we have operated all the pumps, but we have put a valve here, right? So it means that there is no flow in the piping system, and we are operating all three pumps, but because there is no water going forward, so it means that it is the shut-off head for all three pumps, right? So it would give us the maximum head, but we cannot use that head because there is no volume flow rate in the piping system. So that is the maximum possible head which is available by the combination of these three pumps, right? So, but that is of no practical use because we don't want that to happen. That we have switch of the switch of the fluid supply, and we are operating the pump, and there is no use of that, right? So we don't want to do that. So I hope that I have kind of given you a better explanation that would point A, B, and C. And if we ideally if we are using these three pumps, then the volume flow rate which we are going to use, that should be less than the free delivery point of the smallest pump, which is point A. So it means that if we operate our this pumping system at a volume flow rate which is less than the volume flow rate at point A, then we are achieving the best out of this system. But if we operate it beyond point A and less than point B, then we need to make sure that pump one is switched off and the line is bypassed by RT. So the fluid which is coming out of pump 2, it would go directly without passing through pump 1. Otherwise, we are going to experience more losses in pump 1 rather than any net useful work. And similarly, if we want to upgrade at a higher volume flow rate, then at beyond point B, then only pump 3 should be activated and these 3 should be kind of cut off just to make sure that we have got. So these are also written here in the diagram as well. If I can show you here, that if you see the first red line, so it is showing that if the volume flow rate is greater than this arrow is showing, then pump 1 should be shut off and bypass. So what is bypass here? That bypass we have shown it by this T joint. So it is going to be bypass here, and there would be a valve here as well. So that would be fully open if the volume flow rate is in between this. Otherwise, it would be fully closed. This valve. Let me yeah. This valve would be closed when the volume flow rate is less than the volume flow rate at point A. Otherwise, it would be fully open and this valve would be closed. Right? So I hope that you can understand this point. And then there is a second red line. Pump 2 should also be shut down in addition to pump 1. So it means that pump 2 and pump 1 should be both should be cut off and bypassed, and it should go directly from there like this, right? But that is not desirable. Why it is not desirable? Because if we are doing that, then we are kind of wasting our money because we have installed two pumps and we are not getting any useful work out of them, and we are bypassing them. So that is not what we want to do ideally. Because if we have installed them, then we need to make sure that the volume flow rate at which we are operating, that is well beyond the well less than the free delivery point of the smallest one. So in order to get net useful work out of all the ones. So I hope that this point is clear to you all. So if there is any query, you can ask, because these are the things which you need to do when you select a one singular pump, or you decide that whether we want to use multiple pumps in series for a particular application, like gas power plant, because we need to circulate water or steam uh, from inside the condenser just to remove heat or add uh, add fuel into that. So we need to use some pumps in that. So all these considerations come into play when we talk about a very huge power plant, right? So these are the decisions you need to make as a design engineer, right? So these are quite practical aspect of our knowledge, which you should kind of take into consideration or give it a thought, rather than doing only the numerical problems, because they are only for the demonstration purpose, right? So I hope that this point is clear to you all. I have told you all the intricacies involved for the forms installed in series. Now we talk about a situation where we will need to increase the volume flow rate in a piping system. So it means that it is just like a situation. Let me give you a uh, practical uh, practical scenario for that. Pump in parallel. Pump in parallel arrangement. Okay, let's suppose that there is a lake and we are taking water from here and we are giving it to a society, housing society, having kind of 100 homes, right? So we kind of and the distance between that housing is the same, kind of maybe 10 kilometers, whatever. So we design a piping system and we provided the water to those 100 homes. Now, after some time, that society you kind of introduce a phase two here. So this was phase one, this is phase two. So it means that now it also requires it needs to double its and it has also got 100 homes. So it means that now it needs to double its water supply. So what would they do that whatever arrangement they have put here, they would try to put pump in parallel arrangement to increase the volume flow rate. So it means that volume flow rate can be increased by putting pumps in parallel. And this parallel arrangement is very, very frequent in industry. Where we could have got a very large steam, uh, steam power cycle or gas power cycle or kind of gas turbine. So there we usually use more our nuclear power plant for that matter, because in nuclear power plant the thing is very hot when it comes when it do the useful work on the turbine, and then we need to take that steam out of we need to cool it down. So so that we usually have the pumps in parallel arrangement, right? So pump in series, that is usually we install them that when we increase the length of the piping system to to overcome the losses, right? We usually use the pump in parallel when we have got the requirement of large volume flow rate, and that is very common in industry, right? So this arrangement is quite common. So let me show you the characteristic curve for the pump arrangement in the in parallel. So as I explained that the volume when we install the pump in parallel, the volume flow rate through the net volume flow rate through the piping system would be the sum of individual volume flow rates through the pump. So let me show you the characteristic curve for the pump in parallel. Okay. Now, these are the characteristic of those three pumps which are installed in parallel. So now you can see that pump one is the kind of a pump which has got the minimum capacity in terms of volume flow rate, and then pump two is the pump with the intermediate capacity, and pump three is the pump with the largest capacity. And now if I kind of show you that what does it mean, that if we are operating the this system at a head requirement which is less than this first let me highlight this maybe so if the head requirement of this pipe this pumping system if it is less than this green line, right, then it means that all the pumps are adding the volume flow rate, right? It is kind of this V1 plus V2 plus V3. So it means that the volume we would have the volume flow rate coming out of that piping system would be something like V1 plus V2 plus V3 dot. So dot is just for the combined capacity of the that pumping system. So, so but if the net head becomes higher than this point, this green line, then it means that this pump one should be cut off, and then we would have capacity of that pump reduced to this V2 plus V3, right? And then similarly, if the net head is that head at which the pumps are operating that goes beyond the red line, which is this top line, then pump two should also be shut off, and then only pump three would be functioning, but that is not desirable again. So it means that in ideal conditions, the net head which at which these pumps should be selected or operated, it should be below this green line, right? Otherwise, there is no point of installation of these smaller pumps. Or rather, and then extending that discussion, usually we solve a pump having similar kind of capacities or sizes. So let me show you that picture as well, that of a practical situation, pump in parallel where we usually what we do that we kind of put the same pumps, same capacity pumps in parallel. So then in that case, that discussion, that this discussion of the this discussion of having pumps of different capacities that wouldn't be there. In that case, there would be only one curve for several pumps, and we know that what is the shut-off head for the piping system, because in that case there would only be one shut-off head if there are same pumps put in parallel. Right. So these discussion of this that green line, they are valid when we have got pumps of different capacities, right? So then we can see that combined capacity of this this of this piping system when we operate it below this green line. Otherwise, it reduces to this V2 plus V3. So it means that if the pump one is low, then the maximum volume flow rate we can get out of this system, that is only up to this point, right? And if we kind of so we are talking about operating in the range of this this thing, right? If we are operating the in this net head range, then the maximum volume flow rate we can have, that would be only this. And if we are operating in this range somewhere here, then the maximum one can be up in here. Right? So you can easily see that we need to make sure that we are getting the maximum out of the stored functions. Right? Whether that is in parallel or that is in series, so we need to make sure before designing that pumping system, that what is the flow volume flow rate requirement and what is the net available. So that piping.
पैरेलल पंप में सर नेटवर्क सेम ही रहेगा सभी में।
Sorry, Matt, if you can repeat your question.
द वैल्यू ऑफ हेड जो अवेलेबल हेड और रिकॉर्ड हेड सर सेम ही रहेंगे सर अगर हम पैरेलल में पंप यूज करेंगे।
बिल्कुल सही रहेंगे, क्योंकि वो हमने पढ़ा हुआ है ना कि जब रेजिस्टेंस दे आर इन पैरेलल तो वोल्टेज उनके क्रॉस सेम ही रहती है ना, और ज्यादा किस में से वो फ्लो करता है जिसकी रेजिस्टेंस कम होती है। इस केस में अगर मैं वो तीन पंप इंस्टॉल यहाँ पे आपको स्कीमेटिक शो कर दूँ, एक मिनट, and let's suppose I put a schematic where we have got two pumps. Okay, I have got that schematic right on here, so let me show it. Just a minute. Just a minute. Okay. So this is the piping system map, pump one. This is pump two. The net head which is across this, that would be the same. Now tell me whether the higher volume flow rate would go through pump one or pump two. Math, maybe it would be from pump one.
Yes, sir.
Okay. Does it answer your question, or you were asking something else? You intended something else to ask. Is it clear?
ऐसा क्लियर है
Okay, thank you.
मतलब
जी
हमें
बताइए।
वॉल्यूम फ्लो सर ये बेसिकली वॉल्यूम फ्लो रेट इंक्रीज करने के लिए था।
जी ये वॉल्यूम फ्लो रेट यानी कि पहले वो अगर नेट हेड आपके पास जो पाइपिंग सिस्टम है वो जो कि आपने इंक्रीज करना है वो है तकरीबन 20। तो 20 के क्रॉस अब आपने वॉल्यूम फ्लो रेट भी इंक्रीज करना है, तो उसके लिए आप फिर आप पंप को पैनल में लगाते हैं। जैसे कि आप ये इलेक्ट्रिक सेक्टर में भी ये होता है ना कि पैनल में लगाते हैं तो करंट सब डिवाइड हो जाता है, ठीक है, और जो टोटल करंट होता है वो समेशन फ्रॉम ऑल द ब्रांचेस। So similarly, we put a pump in parallel when we have got the requirement of increasing the volume flow rate, and we put pump in series when we have got the requirement of increasing the net head across the pumping system. ठीक है, is it clear? मैं